Strings are my favorite. Strings are an abstraction, a representation of textual data. I call them an abstraction because we don't care about the details of exactly how they're encoded. But they do represent information. And they can represent numbers, and the way we write numbers can all be represented with a string. Here we have scientific notation, here we have some point, and all of these are just strings that somehow tell us information. They can represent language. And as imagination bodies forth the forms of things to unknown, and the poet's pen turns them to shapes and gives to airy nothing a local habitation and a name. I think when Shakespeare wrote Midsummer Night's Dream, he was talking about computer science and abstraction. You can also use strings to represent programs. So here's a string that defines the curry function. And Python source files are just strings. So if I put this in a source file and executed it, then I would have defined the curry function. And by the way, if I start up Python and create exactly that string, curry lambda f, lambda x, lambda y, f of x comma y, it's just a string. But if I execute that string, well then, I've just defined curry. And if I query the add function using what was just a string before, I can in fact add numbers together. So, some details about strings that you may have discovered already throughout the course, but I'll go through them now. There's 3 different ways to write down a string. I can use single quotes, I can use double quotes, and they're the same, except for that if you put an apostrophe in the middle of a double quoted string, it works out fine. But if you do that in the middle of a single quoted string, well then it would end the string. You don't have to just put English characters in the string. Ni hao is fine. Single quoted and double quoted strings are equivalent. A triple quoted string can span multiple lines. So I use those a lot for doc strings because a lot of times doc strings will extend to multiple lines when you add doc tests. Now, when I evaluate this multiple line string, what it shows me at the end all fits on one line. And what's happened is, it's used a special symbol to encode the end of one line and the beginning of another. This is called a line feed. So whenever you see a backslash inside of a line, that escapes the following character. And what that means is that the 2 characters together, this backslash and the following character, really are just one thing in the sequence of letters that is the string. And this \n means line feed, which means start a new line. Strings are sequences. The length and element selection operations are similar to what you'd expect. So the length of the city of Berkeley is 8, which means there are 8 letters. Each letter is called a character. Actually, element selection has the same indexing scheme, 0, 1, 2, 3, but the result is not quite what you might think. So what you get back is a string, even though what you selected from was a string. Now, lists don't work like this. If you had a list of numbers and you selected the element at index 3, you would get a number, not a list. But for strings, you get a string, but with only one element, only one character in it. In and not in are a little bit different for strings than they are with other sequence types. So, instead of looking for only individual letters inside this sequence of letters, you can look for whole words. So if I say is here in where's Waddle, though, it will tell me true. But if I said if 2, 3, 4 is in here, even though 2, 3, and 4 are next to each other, it would say false. And if I looked for the list in here, that would be false as well. So lists, you can only look for one element at a time, but in strings, you can look for consecutive letters. And that's because most of the time when you're working with strings, you actually care about whole words, more than just individual letters. So strings are a special abstraction, which are like sequences in many ways, but they behave in a way that's slightly different from other sequences.